Hello, this is Miss Lumley. Welcome to the Radical Functions Test Review. So let's start with our next problem. We're going to do problem 10 where we're simplifying the radicals. To do this, what I like to do is take the numbers and the variables and do them separately. So I'm going to do the 45, and then I'm going to do the x to the 5th, and then I'm going to do the y to the 9th. Okay, notice that this is a square root. So with the square root, I'm wanting to square root everything that I can that's inside 45, and then also I'm looking to see how many x squareds I can get out of x to the 5th and how many y squareds I can get out of y to the 9th. So that's what I'm looking for, things that are squared. Okay, inside of 45 is a 9 and a 5. So if I take the square root of 9, that is 3. That one's the one that's going to come out, and the one that's going to stay in is the 5. Okay? All right. How about if we do the x's? With the x's, I can see that there are 2x squareds plus an x to the 1. That'll make 5. So how many x squareds are in x to the 5th? There are 2. There's one here and one here. Those 2 are going to come out. These 2's will cancel each other with the square root. So if that one comes out, that's 1, that makes 2. There are 2 x squareds inside of x to the 5th, and there is 1 left over. Okay? If I go in and do the same thing with the y, I'm looking for how many y squareds are inside of y to the 9th. There are actually 4 of them. 1, 2, 3, 4. So the 4 goes here, y to the 4th. So 4 of them are going to come out, and 1 of them is left over. Okay, so what I've done is I've done the numbers and then each variable by itself and put my answer back together. I take out whatever I can. I put it on the left-hand side outside of the radical sign, and then inside the radical I put whatever is left over. Okay, let's do number 11. So with number 11, I'm square rooting these again. So in number 11, I'm going to just move down here for a second. Okay, and what I'm going to do is I'm going to square root the 48, and I'm going to square root x to the 6th and y to the 11th. Okay, all right, so inside of 48, I know that there is a 16 and 3. Now, really what I want, the best way to do this is to find the number that square roots and find a number that doesn't square root. If 3 still had something in it, then I would not want to use it. So let's, for example, on 48, okay? 48, if I used 4 and 12, yes, 4 does square root, but 12 still has another 4 in it, which means I have to do extra work. So that's why I'm picking 16 and 3, because it's the best one to pick. I don't have to do as much work, and on top of that, immediately I get my answer. So if I square root 16, and let me go back to my pen here. If I square root 16, I've got the square root of 16 is 4. That one comes out. And then the 3 has to stay on the inside because I can't square root of 3. Now I go to my variables, okay? With my variables, I have x. How many x squareds are inside of x to the 6th? So you might be able to do this in your head, but there are 3x squareds. So I'm going to do this. Why do I count 3? Well, because 1x squared, if I got it inside the radical, they basically cancel each other out. An x squared and a square root make it just an x. If I do that 3 times, 1, 2, 3, I've taken 3 x's out. So basically, it's an x cubed. Okay, so I'm going to do it again with the y's. How many y squareds do I have inside of y to the 11th? It's y squared, y squared, y squared. There's 3, 4, 5. That will make y to the 10th. So I'm going to take out 5 y squareds, which will make y to the 5th because they're canceling. So then I have, there were no x's left, so good, that's good. And there's one y left because that makes your y to the 11th. So my final answer is 4x cubed y to the 5th square root of 3y. Okay, so now let's switch to our cubes. So notice that we have to cube this. In other words, we're not looking for squareds anymore. We're looking for 3 of something. And again, I'm going to take this and divide it up into the 24. Now, as the reason why I do this is so that you can have a visual of how I actually work these problems. So basically, I'm dividing everything up. Let's make sure I did it correctly because I might miss something. So I've got the cube root of 24, the cube root of x to the 7th, the cube root of y to the 11th, and the cube root of z to the 15th. Now, do you have to write it out like this? No, you do not. The reason why I do it is for you, but really what I do is I just take the 24, do it first, and then I do the x, and then I do the y, and then I do the z. Okay, so on the 24, let's do this like this. So on the 24, I'm going to go, what can I cube root? Well, those are different numbers than the square roots. And on the 24, I can cube root an 8. Those are the best numbers to use. When you cube root an 8, what are you going to get? A 2. So I'm going to put the 2 on the outside, and I'm going to make sure I put my cube in here so we all know this is a cube root. And the 3 stays on the inside. There's that 3 right there that goes on the inside, okay? So that's part of my answer now. Now all I have to do is the variables, but this time I'm looking for x cubes. So how many x cubes are in 7? I can get 2 of them. Okay, because 2 of them times 3 would make x to the 6th. Okay, so then I've got, let's see, that's 2, so I've got 1 left over. How many y cubes can I get inside of y to the 11th? That would be 3, because 3 of them would make y to the 9th. So y cubed, and then I have 2 left over, so I gotta, okay. Notice if I take 3 times 3, that's 9. 9 plus 2 more makes 11. Okay, so that's another way that I can check. All right, let's do the last one. Z to the 15th. How many z cubes are inside of 15? Well, I can do this but just by division, go 15 divided by 3. That's actually z to the 5th. Okay, so I ran out a little bit of room there, but you can see what I've done. So my answer is 2x squared y cubed z to the 5th, the cube root of 3x y squared. Okay, so we're going to do a few more of these. That was number 12. Let's see what we have next. Okay, so for 13, we're cube rooting again, and I'm going to split it up. So let's do the cube root of 625, and then the cube root of x cubed, and the cube root of y to the 5th, and the cube root, I'm running out of room, but that's okay, z to the 7th, okay? So here we go. Now, I would say that if you don't know that 5 cubed is 125, then just start dividing by 5 and see what you get, okay? Or go 5 times 5 times 5 in the calculator. If you go 5 cubed in the calculator and get 125, and then if you divide 625 by 125, you'll get 5. You'll figure it out just by kind of logically thinking, what number do you think could go in there? Okay, so let's take that out real quick. All right, and let's go back to 125. So the cube root of 125, remember that this one is going to be the one I want to take out. So the cube root of 125 is 5. Okay, and this 5 is the one that's going to go back on the inside because it doesn't cube root. Okay, this was actually a 3 here. So the cube root of x cubed is just x. I can get 1x cubed out of all that. So 1 of those comes out because these two are canceling each other. Okay, I can get 1y cubed out of y to the 5th, okay, and there's 2 left over because that would make 5 y's. So 2 left over has to stay inside the radical. And I can get 2 z cubes out of z to the 7th. That's going to make 6, 2z cubes. So 2 of those will come out. And, well, it's actually 6 of them come out, but you can only write it 2 times because you're really canceling this cube root with these, okay? And there's 1 z left over. So my answer is 5xy z squared cube root of 5y squared z. Okay, so like I said, I'm running out of room, so I'm going to go put this one down here. Okay, and oh my gosh, now we have a 4th root. Okay, so I'm going to 4th root the 32. Okay, and I'm going to 4th root the x to the 9th. I'm going to 4th root the y to the 14th. And I'm going to 4th root the z to the 16th. I'm going to do it the exact same way every single time. Inside of 32, the one that we talked about was 16. The 4th root of 16 is 2. So this one, the 4th root of 16 is 2, which means it comes out of the radical. And then I'm going to figure out what the rest of my answer is. Okay, now the 2 is going to have to stay inside the radical because I can't take a 4th root of 2. All right, so I'm looking for x to the 4th. Okay, how many x to the 4ths can I get out of 9? I can get 2. If I get 2, that's actually x to the 8th. Okay, so this would be taking 2x to the 4th out, and I have 1 left over. Okay, how many y to the 4th can I get out of 14? Well, I know 4 times 3 is 12. So that means that I can take out 3y to the 4th. Okay, 3y to the 4th. With that, if there's 12, if I've dealt with 12 of them, then I have 2 of them left over. Okay, and of course 16 divided by 4 is 4, so that makes z to the 4th. I can take out 4z to the 4th. Okay, I know that sounds like a lot to say. So now my final answer is right here. 2x squared y cubed z to the 4th, and then the 4th root of 2xy squared. Okay, our last problem for this video is going to work with the 5ths. Okay, so we're going to do that right here, and we're going to take and do the 5th root of 64, the 5th root of x to the 8th, the 5th root of y to the 14th, and the 5th root of z to the 15th. Okay. Now, let's see here. 64 is 32 times 2, okay? Because that 32 times 2 is 64. The 5th root of 32 is actually 2. And then I have this 2 is left over. Okay, let's put our 5 in here so we don't lose points for not stating what our root is. Okay, now I'm looking for x to the 5th. How many x to the 5ths are inside of 8? I can only get 1. That means that if I take out 5 x's, I'm going to have 3 left over. Okay, how many x to the 5ths are in y to the 14th? That would make 2. So that means there's 10 of them that I'm taking out, and now I have 4 left over. Now how many z to the 5ths are inside of 15? That's 3 of those. And I don't have any left over. So there's my final answer. I've got 2xy squared z cubed, 5th root of 2x cubed y to the 4th. And then I'm done. Alright, well that is it for this video. Please let me know if you have any questions, and thank you for watching.